Welcome back to our next session here on Djji Tutorials. Hope you're ready for this next topic on angles and degree measure. An angle is a geometric figure formed by two rays or line segments that share a common endpoint called the vertex. Degree measure is a unit used to quantify the opening or rotation between those two rays, with one full circle or a complete rotation being 360 degrees. Here's a more detailed explanation. Angles. An angle is formed when two rays intersect at a single point. The point of intersection is called the vertex. The two rays are called the arms of the angle. Angles can be classified by their size: acute less than 90 degrees, obtuse greater than 90 degrees, and less than 180 degrees. Right exactly 90 degrees and straight exactly 180 degrees. Angles are measured using a protractor, a tool with markings indicating degrees. Degree measure. A degree, denoted by the symbol degree, is a unit of measurement for angles. One full rotation around a circle is equal to 360 degrees. Therefore, 1 degree represents 1/360th of a full circle. Angles are measured in degrees, with a positive direction being counterclockwise or anti-clockwise and a negative direction being clockwise. A right angle, for example, measures 90 degrees, and a straight angle measures 180 degrees. A radian is a unit of measurement for angles, specifically in the context of circles. It's defined as the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. In simpler terms, 1 radian is the measure of the angle formed when you wrap the radius of a circle around its circumference. Key aspects of a radian: ratio of arc length to radius. The radian measure is essentially the ratio of the arc length to the radius of the circle. Unit of measure. It's a unit of angular measure, just like degrees. Relationship to degrees. 1 radian is approximately equal to 57.2958 degrees. Usage in mathematics and physics. Radians are commonly used in calculus and trigonometry as they simplify certain calculations. Unitless. Since it's a ratio of lengths, the radian measure is considered unitless. Radian measure is a way to quantify angles using the ratio of arc length to radius of a circle. Specifically, a radian is defined as the central angle of a circle where the arc length is equal to the radius. This means that 1 radian is the measure of an angle that, when used to define an arc, has a length equal to the circle's radius. Here's a more detailed explanation. Key concepts. Arc length, denoted as S, is the distance along the curved edge of a circular arc. Radius, denoted as R, is the distance from the center of the circle to any point on its circumference. And finally, radian, abbreviated as rad, is a unit of angular measure, where 1 radian is the angle subtended by an arc whose length is equal to the radius. The radian measure of an angle, often denoted as theta, is given by the formula theta equals S divided by ER. Why use radians? Well, there are a few compelling reasons. First, they are a natural unit. In many mathematical and physical contexts, radians are the preferred unit because they provide a natural measure of angles based on the geometry of circles. Second, they simplify trigonometry. Using radians simplifies trigonometric functions and calculus-based applications involving angles. Finally, they offer consistency in units. Radians are a dimensionless unit, which means they don't have any physical dimensions like degrees. This makes them suitable for situations where you want to combine angular measures with other physical quantities that have dimensions, according to Better Explained. A full circle, which is 360 degrees, is equal to 2 pi radians. Therefore, 1 radian is approximately 57.3 degrees. To convert degrees to radians, you multiply by pi over 180. And to convert radians to degrees, you multiply by 180 over pi. Let's look at an example. An angle of 90 degrees is equal to pi over 2 radians, and an angle of 2 pi radians is equal to 360 degrees. To convert an angle from degrees to radians, you multiply the degree measure by pi over 180. For example, to convert 90 degrees to radians, you would multiply 90 by pi over 180, which results in pi over 2 radians. Here's a more detailed explanation. Understanding the relationship, a full circle is 360 degrees, which is also equal to 2 pi radians. Therefore, 180 degrees is equal to pi radians. The conversion factor. Since 180 degrees equals pi radians, we can establish a conversion factor. 1 degree equals pi over 180 radians. To convert degrees to radians, you multiply the degree measure by the conversion factor pi over 180. Example. Let's say you have 45 degrees. Multiply 45 by pi over 180. 45 times pi over 180 equals pi over 4 radians. To convert an angle from radians to degrees, you multiply the radian measure by 180 degrees over pi. This conversion is based on the fact that 2 pi radians equals 360 degrees, or pi radians equals 180 degrees. Here's a step-by-step explanation. First, identify the angle in radians. Determine the angle measure in radians, which is typically expressed in terms of pi, for example pi over 2, 2 pi over 3, and so on. Then, multiply by 180 over pi. Multiply the radian measure by the conversion factor 180 over pi. Alright, let's simplify the result to find the equivalent angle in degrees. For example, if we want to convert pi over 3 radians to degrees, we start with the angle in radians, which is pi over 3. Next, we multiply by 180 over pi. So that's pi over 3 times 180 over pi, which equals 180 divided by 3. Simplifying that, we get 60 degrees. Therefore, pi over 3 radians is equal to 60 degrees. To determine the length of an arc of a circle with a given radius, you need to know the central angle of the arc. If the angle is in radians, the arc length is simply the radius multiplied by the angle s equals arth. If the angle is in degrees, you need to convert it to radians first by multiplying by pi over 180, then use the formula s equals arth. Here's a more detailed breakdown. 1. Understand the formula. Arc length, s, is the distance along the curved path of the arc. Radius, r, is the distance from the center of the circle to any point on its circumference. Angle, theta, is the central angle of the arc. This can be measured in either radians or degrees. 2. Radians. If the angle theta is given in radians, the formula is s equals arth. For example, if the radius r is 10 centimeters and the angle theta is 2 radians, then the arc length s is 10 times 2, which equals 20 centimeters. 3 degrees. If the angle theta is given in degrees, you need to convert it to radians. The conversion is theta in radians equals theta in degrees times pi over 180. The formula then is s equals r times theta in radians. For example, if the radius r is 10 centimeters and the angle theta is 60 degrees, then the arc length s is calculated as follows. First, convert 60 degrees to radians. 60 times pi over 180 equals pi over 3 radians. Then calculate the arc length s equals 10 times pi over 3, which is 10 pi over 3 centimeters, approximately 10.47 centimeters. We hope you find this lesson useful. Please share with your friends. See you in part 2.